Hello, welcome to the answers to question 7 on paper 1 from November 2008. Question reads, let f at x equal sine cubed x plus cosine cubed x times tan x. For the domain pi over 2 is less than x, which is less than pi. Part A says, show that f at x is equal to sine x. So all we have to do is simplify this function down to sine x. So first thing that we need to do is get rid of this tan here. So if you look in the data booklet, you'll find that tan x is really just equal to sine x over cosine x. So we have sine cubed x plus cosine cubed x times, tan x is equal to sine x over cosine x. Once we have this, we can cross out the cosine x here. We can cross out the 3 here and have a 2. And then we get f at x is equal to sine cubed x plus cosine squared x times sine x. Now we have a common factor here, sine x, and a sine x from here. So we can factor that out. We get sine x times sine squared x now plus cosine squared x. Now, if you look at your trigonometric identities, you'll find that sine squared x plus cosine squared x equals 1. So we have sine x times 1, which is just sine x. Now we've shown that f at x simplified becomes just sine x. Part 2 reads, let sine x equal 2 over 3. Show that f at 2x equal negative 4 root 5 over 9. Okay, so when you have f at 2x, you have f at 2x, you have sine at 2x. Because you multiply all x values by 2, obviously. Now this is the double angle. So you go into the data booklet again, you find the double angle formula, and you'll find that sine 2x equals 2 sine x times cosine x. Now, in the question, they've given us the value for sine x, so we have 2 times 2 over 3, but we need to find the value of cosine x. So all we have to do is go over to this little right triangle. We'll call this angle x, and we know that sine is opposite over hypotenuse, so we have opposite over hypotenuse, 2 over 3, it's given in the question, and then using Pythagoras' theorem, we can solve for this side. Let's just call it y for now. So y squared plus 2 squared will equal 3 squared. Solve for y becomes y squared equals 9 minus 4, which is 5. So we have y equals root 5. Okay, so this root 5 equals y. Now the cosine value will then be adjacent over hypotenuse, which is root 5 over 3, but there's another trick here. See, in the question it gave us the domain pi over 2 is less than x, which is less than pi. Now if you look at the Cartesian plane, we have pi over 2 is less than x, which is less than pi. So our value has to be somewhere within this quadrant, and in this quadrant only the sine values will be positive. So the cosine value we found here is really negative root 5 over 3. Now, all you have to do is multiply 2 by negative root 5 becomes negative 4 root 5 over 3 times 3, which is 9. Now you've shown that f at 2x equals 4 root 5, negative 4 root 5 over 9. That's all there is to it.